It is my pleasure to introduce this episode of ItaCa, the November one. Before introducing the first speaker, I would like to just spend 1 minute, even less, advertising December's event. So it's going to be slightly different in that we're planning a bigger event. So it'll be spread from, so there will be a section in the morning and then one in the afternoon. We're still finalizing the speakers and we will let you know as soon as possible, but we would like to see as many people as possible because it's going to be sort of ItaCa's Christmas party. So the first speaker that I would like to introduce for today is Davide Trotta from the University of Verona with a talk entitled The Existential Completion, Choice Principles and Applications.
So, thank you very much. Do you see my slide now?
Yes.
Perfect.
Yeah.
Okay. So, in this talk, I would like to present a joint work with Mili Maietti and Margherita Zorzi on the existential completion, its connection with some choice principles and applications. So, the main language that I will use today is the language of doctrines. And I want to recall that the notions of primary doctrine or existential doctrine or elementary doctrines are a natural generalization of the notion of hyper-doctrine introduced by Lovier to provide a categorical framework for first-order theories. Now, the intuition, for example, is that an existential doctrine is a functor which has the right structure to interpret an existential quantifier. And similarly, an elementary doctrine is a doctrine which can interpret the quality in the correct way. So this is the intuition. Now, the main goal of this talk is to present a free construction called existential completion, which essentially produces an existential doctrine starting from a primary one. And I want to give a complete description of this construction, and we will see how this construction is related with some choice principles as the rule of choice or the Hilbert epsilon operator. And in the second part, I want to show how we can generalize this completion, and I will provide some examples. So I want to briefly introduce this construction, and then we will see all the details. Well, as anticipated, the existential completion is a free construction that produces an existential doctrine starting from a primary one. This construction induces a two-monad in the two category denoted in this way of primary doctrines. And this two-monad has the following properties. First, the two category of its algebras is equivalent to the two category denoted in this way of existential doctrines. This means that the existential structure of a doctrine is represented by an action which gives to a doctrine P the structure of algebra for this monad. Now, this two monad is lax idempotent, so this action is unique. And what I want to explain is that this action contains a lot of information about the features and the properties of the existential structure on P. So this is the main purpose of this first part. In particular, we know that there is equivalence between the two category of algebras and the two category of existential doctrines. And I want to show what are the existential doctrines which corresponds to the free algebras for these two monad, and what are the existential doctrines which correspond to the idempotent algebras. So this is the main goal of this first part. I want to fill this diagram. Now, we can start with the first definition. So, in a primary doctrine is a functor from the opposite of a given category with the finite products to the category of imp semilattices. So we have that each fiber is a poset with finite maths. The intuition behind this definition is that an element of a fiber is essentially a formula in a given context. And the base category, in some sense, represents the category of contexts. So this is the logical intuition. And the order in a fiber is given by the probability. A primary doctrine is said existential if for every A1 and A2, for every object A1 and A2 of the base category, and for any projection, the functor denoted in this way, which is the evaluation of the doctrine P on a projection, has a left adjoint, and this satisfies the Beck-Chevalier condition and the Frobenius reciprocity. Again, as I anticipated, this is exactly the right structure to interpret an existential quantifier in the correct way. For example, the Beck-Chevalier condition means that the left adjoint commutes with the weakening functors in the correct way. So this is the meaning. A primary doctrine is said elementary if for every object A, there exists an object in the fiber on A times A, denoted in this way, which is essentially the equality predicate, such that this assignment for an element alpha of the fiber on P of A gives a left adjoint to the functor given by the evaluation of the doctrine on the diagonal. And for every morphism A, which is of the form identity times diagonal, we have that this assignment gives a left adjoint to the functor which is given by the evaluation, again, of this doctrine on the morphism identity times diagonal. So these are the three kinds of doctrines that I will consider in this talk. For more detail, I refer to the, for example, to the work of Maietti and Rosolini. And I want to provide some examples. And the first one is a well-known example of primary doctrine, which is the subobject doctrine. So in this case, let C be a category with finite limits, and the functor is given as follows. For every object, it assigns to this object the poset of its subobjects, and for any arrow F in the base of the base category, this functor is given by pulling a subobject back along F. Notice that this is not an existential doctrine in general. It is existential and elementary if and only if the category C is regular. So this is a well-known example of primary doctrine. The second example is the weak subobject doctrine. Well, in this case, we consider a base category D such that it has finite products, but only weak pullbacks. So in this case, the doctrine is given by the functor of weak subobjects, where with this notation, this is essentially the poset reflection of the slice category on A. And again, for every arrow, we have that this functor acts is essentially given by a weak pullback along F. And this doctrine is an existential doctrine. So these are the two main examples that I will use in the last part of this talk. Now I want to recall the two categorical structure of the two category of primary doctrines. Well, the two category of primary doctrines has the object are the primary doctrines, and one cell is given by a pair where the first component is a functor which preserves products, and the second component is a natural transformation from the functor P to this composition. A two-cell is a natural transformation from F to G, such that for every object A of the base category and for every element alpha in the fiber, we have that this inequality holds. So these are the one cells and the two cells. Similarly, we can define the two category of existential doctrines and the two category of elementary doctrines. In this case, for example, if we want to define the two category of existential doctrines, we need to require that one cell, well, we want that the natural transformation commutes in the right way with the left adjoints. So we require that one cell preserves the existential structure. And similarly for the one cell of elementary doctrines. The two cells remain the same. So these are the two categories of primary, existential, and elementary doctrines. Now, I want to recall two definitions involving two choice principles that I will use when we characterize the free and the idempotent algebras. And the first one is the following. For an existential doctrine P, we say that P satisfies the rule of choice if for every element phi of this fiber, such that this statement is true, there exists an arrow, which is essentially a witness, such that an arrow in the base category, such that this is true. So this is the rule of choice. For example, the weak subobject doctrine satisfies the rule of choice. Now we say that an existential doctrine is equipped with epsilon operators if for every object B and A of the base category and for any element alpha in the fiber, there exists an arrow from A to B denoted in this way, such that these two propositions are probably equivalent. Notice that this is a very strong requirement. In particular, we have that if an existential doctrine is equipped with epsilon operators, well, in particular, it satisfies the rule of choice. So these are the two choice principles which are involved in the characterization of the idempotent and free algebras for the monad. Now we can start with the existential completion. So I want to recall this construction, and as I anticipated, it is a construction that produces an existential doctrine starting from a primary one. So let P be a primary doctrine. The existential completion, denoted by Px, is a new doctrine which has the same base category, and for every object A, the poset is defined as follows. An object is a triple where the first two elements are objects of the base category, and the third one is an element of the fiber on A times B. The intuition is that the first object represents the free variables, and the second one, the bounded variables in Px. This is the intuition. The order is given in the following way. We say that A, B, and alpha is less or equal to A, C, and beta if there exists an arrow, F from A times B to C, such that this inequality holds. So this is the existential completion. This assignment raises to a free construction, and we have that the new doctrine we have defined is existential, and the two monad, which is induced by this free completion is lax-side idempotent. And we have that there is an equivalence, an isomorphism between the two categories of existential doctrines into the two categories of algebras. So this is the equivalence I anticipated in the introduction. Now, I want to show a first application of this construction. And we know from the work of Maietti and Rosolini that there is a B-adjunction between the two categories of exact categories into the two categories of elementary and existential doctrines. This is the exact completion of an elementary and existential doctrine. Now, using this construction, we can extend this completion in the following way. We have that the existential completion preserves the elementary structure, and then we can consider the two functors from the two categories of exact category into the two categories, denoted in this way, of elementary doctrines. And this two functor has a left B-adjoint. So this is the first application. If you have any question, please, you can stop me in any moment. Now, I want to introduce a new definition because we are going to characterize the free algebras of these two monads. This definition that I will explain in this slide, well, essentially, it is a categorification of the notion of element which is free from the existential quantifier. This is the intuition. With this definition, we want to give a categorical definition of an object which is free from the existential quantifier. And now we will see the detail. If we have an existential doctrine, an object alpha of the fiber is said P quantifier free if for every arrow F from B to A and for every element beta of this fiber, we have that if this inequality holds, then there exists an arrow G from B to C such that this holds. So an element is a quantifier free if and only if in the internal language it is free from the existential quantifier. This is the intuition. We say that a doctrine P has enough P quantifier free objects if every object is in some sense covered by a quantifier free element, which means that if we have an element alpha, there exists an object B and a P free quantifier element beta such that alpha is equal to this one. This is the other definition. And with these two concepts, we can characterize what are the doctrines which are instances of the existential completion. In particular, we have that let P be an existential doctrine. Well, then it is an instance of the existential completion if and only if the doctrine P satisfies the rule of choice. P has enough P quantifier free objects, and for every P quantifier elements A and B, well, if we consider their inf, it is again a P free quantifier. So this is the characterization. We have that the doctrine must satisfy the rule of choice. The doctrine has enough quantifier free, and the quantifier free elements are closed under binary maps. An application an application of these results, well, gives a proof of the rule of choice for the regular fragment of the logic. Well, if we consider the syntactic doctrine denoted in this way associated to the regular logic, well, this syntactic doctrine is the existential completion of the syntactic doctrine associated to the Horn fragment. In particular, by the previous theorem, we have that the regular fragment of first-order intuitionistic logic satisfies the rule of choice. This is an easy proof of the validity of the rule of choice in this fragment of logic. Well, now I want to characterize those doctrines which corresponds to the idempotent T-algebras. Well, an existential doctrine is an idempotent algebras if and only if it is equipped with epsilon operators. This is the characterization. So the idempotent algebras for these monads are exactly those existential doctrine equipped with epsilon operators. So we have, I want to come back to the initial diagram, and we have seen what are the doctrines which corresponds to the free algebras, which are doctrines which satisfy the rule of choice, which has enough quantifier free elements, and such that the quantifier free elements are closed under binary maths. And we have seen what are the existential doctrines which correspond to the idempotent algebras. So this is the first result that I stated at the beginning of this talk. And before starting with the second part, which is the generalized existential completion, I would like just to make a remark regarding a universal closure operation. Well, if we have a primary doctrine, we can define a universal closure operation on this doctrine, which is essentially an intersect functor from P to P, denoted in this way, which preserves finite maths, is idempotent, and inflationary, which means that the identity is less or equal to this operation. And as usual, given an universal closure operation on a primary doctrine, we call an element a closed if alpha is equal to its closure. And similarly, we say that an element alpha is a dense if its closure is equal to the top element. So these are two standard definitions. And now now we can observe that if we consider an existential doctrine, then its existential completion is endowed with a canonical universal closure operation, which is essentially given by the co-unit and the unit of the adjunction. This is an immediate remark. And an element, A, B, and alpha of the fiber is a closed if and only if there exists an arrow in the base category such that these two are equal, which this means that the closed elements are exactly those element of the fiber of the old fiber. So a closed element are in bijection with the elements of P such that they are equipped with an epsilon operator. This is the characterization. And then an element is a dense if and only if an element of the form A, B, and alpha is a dense if and only if in the old doctrine, so in the doctrine P, we have that this proposition is true. This is just a remark. And now I want to introduce the generalized existential completion. So we have seen that the existential completion freely adds left adjoint along the projection. But the key point is that what we really need in this construction, well, is that the class of projections is closed under pullback composition and it contains identities. So we can easily generalize the existential completion to a completion which freely adds left adjoint along an arbitrary class of morphisms, which is closed under composition, pullbacks, and which contain identities. I don't want to give all the detail. I want just to give you the intuition and the reason why we can generalize this construction in this way. So in this case, given a primary doctrine and a class of morphisms, we denote in this way the generalized existential completion of this doctrine along this class. So this is the generalized existential completion. An example, if we consider the weak subobject doctrine, but we ask that the base category has finite limits, and well, if we consider the class of all the morphisms of the base category, we get that the weak subobject doctrine is an instance of generalized existential completion. In particular, it is the existential completion of the trivial primary doctrine, denoted in this way, such that every fiber contains only the top element. So if we take this trivial doctrine and we apply the generalized existential completion along the class of all the morphisms of D, we get the weak subobject doctrine. So this is a first example. For the second example that I want to explain, we need to introduce the notion of comprehension. So if we consider a primary doctrine P and an element of a fiber, well, a comprehension of this element alpha is an arrow in the base category whose codomain is A, such that when we evaluate this functor on alpha, this is the top element. And such that for every arrow F in the base category, such that P of F of alpha is the top, then there exists a unique map from a unique map G, such that F is equal to this composition. So this is the definition of comprehension. We say that a doctrine P has comprehensions if every element alpha has a comprehension. And we say that P has full comprehensions if, moreover, alpha is less or equal to beta whenever the comprehension of alpha factors through the comprehensions of beta. Notice that if we consider the class of comprehensions, well, this class contains the identities. It is closed under pullbacks, but in general, the composition of two comprehensions is not a comprehension. We have that the comprehension, two comprehensions compose if and only if the doctrine has left adjoint along these comprehensions. So in general, we get that if a doctrine has full comprehension, then this compose if and only if the doctrine has left adjoints along the comprehensions, and this satisfy Beck-Chevalier condition and Frobenius reciprocity. In particular, we have that for if we consider a doctrine with full comprehension and the left adjoints along these comprehensions, which satisfy Beck, Chevalier, and Frobenius, then this doctrine is isomorphic to the sub-object doctrine denoted in this way, where M is the class of comprehension. So this functor sends an object A of the base category into the poset of the sub-object of M, of the M sub-objects. So we do not consider all the sub-objects, but only those sub-objects which are morphisms of this class. So we can conclude with this last example. If we consider a doctrine P such that P has full comprehensions and the comprehension compose, well, this is an instance of generalized existential completion, where the class is the class of comprehensions. And again, this doctrine is the generalized existential completion of the trivial primary doctrine denoted in this way, where in this primary doctrine we have that for every object A, the poset contains only the top element. So this is the last example. I want just to mention another example, but which is not exactly an existential completion, but it is very similar, which is the realizability hyperdoctrine. If we consider this hyperdoctrine, this has enough quantifier free, but these are closed under binary met, but it does not satisfy the rule of choice. So this is an example of a doctrine which is very, very close to an existential completion, but it is not an existential completion because this doctrine, this hyperdoctrine, does not satisfy the rule of choice. And well, with this remark, I conclude, and thank you.
Thanks, Davide, for your talk. Let's have a silent applause for that. And if there are any questions, now it's a good time before we move on to the second talk. So whoever has something to ask, please.
Maybe I have one short question, Davide. What are the future direction you have with after this, or maybe you want to change topic, or there is still something open in this direction?
Well, thank you, Ivan, for this question. Well, this is this work is the second part of another work called in which I introduced this existential completion. So with these results, I believe that maybe we could see something about the closure, the universal closure operation, and how this the main I think that we have all the result that we wanted.
Davide, you could mention the fact that you can dualize the completion and apply these things to the dialectica. Why not?
Yes, this is another point. Well, another application of this construction, but in the context of the vibrations, is in the construct. We can use an existential completion in the context of the vibration. This is a remark of Hofstra, where he proved that the dialectical construction can be broken into different completion. One, which is the existential completion, and the second one, which is the universal completion. So this, he showed that these two constructions, if we compose first the universal completion, then the existential completion, gives the dialectical construction. And well, I think that we can generalize, for example, the definition of quantifier free and enough P-free quantifier in order to provide, in some sense, an internal definition of a vibration which is a dialectical vibration. So this is another application and another direction.
Are there other questions? There's still time. Otherwise, if there are no other questions, we can leave other comments for later. So let's see if there's someone else who wants to say something.
There is an open problem in finding examples for the exact completion starting from a pure elementary doctrine. That to find a genuine example, because we have a lot of examples as hypothesis, for example, as exact completion coming from an existential and elementary doctrine. But for the free construction that Davide in his PhD thesis built, starting from an elementary doctrine, adding the free existential completion, then doing our free completion to from an existential elementary doctrine to an exact category. This at the moment we are looking for genuine examples. At least I'm looking for genuine examples, not just the syntactic ones. Thank you.
Okay, so I think we can move on with the second talk. We're slightly ahead of schedule, but it's no big deal. So Dennis, you ready? Okay.
Yes.
Okay, so it's my pleasure.